What does summer smell like to you? Like, take a second and really put yourself there.
Yeah, just close your eyes for a moment.
Right. For a lot of us, it's not just a season, it's this deeply physical sensory experience. I mean, imagine warm sunlight hitting the grass, the faint trace of wood smoke drifting through the evening air,
Oh, that's the best.
and the heavy, sweet aroma of fresh peaches just bubbling away in a massive pot. Think of a late summer afternoon, you step into a kitchen and find freshly baked bread, just cooled and sliced, and it's spread with butter that melts instantly from the warmth, and then topped with a generous spoonful of that homemade fruit preserve.
It's just such a vivid picture. I mean, there's this profound feeling of like slow living tied to those images.
Yeah, exactly.
Families gathering around food, grandparents practicing these old traditions that, make a house actually feel like a home. It is nostalgia in its absolute purest form.
It really is, and it brings up this fascinating mystery, which is, well, that's what we are diving into today. Our sources lay out this incredible journey of preserving summer fruit.
Right.
We're going to explore the strange magic of making something in the intense heat of summer, specifically for a cold winter day that hasn't even arrived yet.
It's almost like putting time into a jar.
Yes, time in a jar. We want to understand the profound science behind why food, fire, and fragrance are so deeply wired into our most cherished memories.
And, to really grasp why a jar of homemade jam or the smell of a open fire carries so much emotional weight, you have to look under the hood a bit.
Okay, where do we start?
Well, we have to look at the physical architecture of the human brain.
Let's start there, because this is something I've always kind of wondered about. If I look at a faded photograph of my childhood backyard, I feel, a little wistful. But if I catch the exact scent of wood smoke and boiling sugar, I am not just remembering that backyard. I am physically transported back there. My chest feels different. Why does scent hit with so much more force than a photograph?
So it really comes down to how your brain processes incoming data. Smell is actually the only one of our five senses that completely bypasses the filter of the cerebral cortex.
Wait, really? It's the only one?
The only one. When you see a photograph or hear a song or touch a hot stove, that sensory data travels first to a region called the thalamus.
Okay.
The thalamus acts like a relay station. It sorts the data, analyzes it, and then routes it to the appropriate part of the brain for a reaction.
Wait, hold on. So every other sense gets filtered? Like, if I touch a hot pan, my brain takes the time to analyze that data before I pull my hand away, but the smell of the smoke from that pan skips the line.
That is precisely what happens. The olfactory bulb, that's the structure in the front of your brain that processes smell, it has a direct unfiltered pipeline straight into the limbic system.
What?
And the limbic system, well, that houses the amygdala, which processes our emotional responses, and the hippocampus, which forms and stores our memories.
Okay, let me unpack this. So, scent is basically like a VIP pass at a concert.
I love that analogy.
Right. It skips the long security line of the cerebral cortex and goes straight backstage to our emotions.
Yes, exactly. And the evolutionary reasoning for this actually makes total sense.
Because of survival.
Right. Before we had complex language or, high-level reasoning, early humans needed immediate visceral reactions to environmental cues, like the smell of a predator or the scent of a fire.
That makes a lot of sense.
And the data backing this up is staggering. Harvard Medical School found that olfactory memory is 6 times stronger than visual memory.
6 times? That is wild.
Yeah. When a familiar scent hits you 20 years later, your brain doesn't bother distinguishing the present from the past. Neurologically speaking, you are reliving the moment.
Which totally frames this other piece of research in our stack from Jean-Pierre Royer at the University of Lyon.
Oh yes, the social connection study.
Right. He found that scents actively light up the areas of the brain associated with social connection. The smells of our childhood literally map our sense of belonging.
And if we trace that need for belonging back to its origin, we arrive at the smell of smoke.
Ah, right.
Researchers at Cambridge University have proposed that smoke was actually humanity's first collective scent.
Because of gathering around the fire.
Exactly. Early human survival depended on gathering around fires for warmth, cooking, and protection. So the smell of campfire smoke became hardwired into our biology as this ultimate signal of unity.
It's basically the original smell of safety.
It really is. And that ancient biology is still active in you right now.
I mean, I feel it when I smell a campfire.
Well, Columbia University conducted studies showing that exposure to familiar, comforting scents causes a measurable drop in cortisol levels.
That's your stress hormone.
Exactly,
Right.
your primary stress hormone. Your body literally physically relaxes.
And it's not just smelling the environment either, it's the physical act of engaging with it. UC Berkeley studied something they call culinary mindfulness.
Which is such a great term.
Isn't it? They found that the simple act of standing over a pot, crushing aromatic herbs, or stirring fruit actually boosts dopamine levels. You get a neurochemical reward just for participating in the process.
It completely changes how we view those slow, traditional kitchen afternoons, doesn't it?
It really does.
When a grandmother spends hours preparing food, she isn't just providing calories for the winter. She is literally building an emotional dictionary for her family, written entirely in the language of scent.
Okay, let's turn a page in that dictionary because our sources focus heavily on one specific entry for summer nostalgia.
The peach.
The peach. But not just any peach. They focus on the gold standard for preserving, a variety called the Redhaven.
Yes. For a huge portion of people, when they imagine a late July afternoon, biting into a peach that perfectly balances sweetness with a slight tartness.
With the juices running everywhere.
Exactly. They are remembering a Redhaven.
But looking at the agricultural data in our sources, there is a massive contradiction here. We picture this rustic, ancient, intergenerational tradition of picking peaches, but this specific iconic fruit was engineered in a mid-century lab.
It is such a brilliant collision of science and memory. What's fascinating here is that the Redhaven was developed in 1940.
Wait, 1940, so it's not ancient at all.
Not at all. A horticulturist named Stanley Johnston developed it at the Michigan Agricultural Experiment Station. He spent years crossing the Alberta peach with other early season varieties.
Just trying to make the perfect peach.
Right, trying to design the perfect commercial and domestic fruit. And it was an absolute botanical triumph.
Here's where it gets really interesting to me. We assume nostalgia is ancient, but this iconic summer memory was essentially engineered in a 1940s lab. He designed the modern summer memory.
He really did. It has that vibrant red blush over golden yellow skin and firm flesh with red streaks near the pit.
Beautiful.
Crucially, he bred it to be a freestone or semi-freestone peach.
Okay, which means the flesh easily separates from the pit, right, making it much easier to process.
Exactly.
Because our sources describe this beautiful family tradition of washing the fuzz off the freshly picked Redhavens, slicing them into quarters, then halves, and finally cutting them perpendicularly into eighths.
So you get those perfect little pieces?
Yeah, and the firmer pieces hold their shape while the softer parts melt into a rich puree. You need a freestone peach to do that efficiently.
You do. But you also need a tree that survives. Johnston grafted these perfect peaches onto a highly specific base, known agriculturally as a BY529 rootstock.
Okay, let's break that down for a second, because that alphanumeric code sounds a bit clinical for a cozy summer afternoon deep dive.
Fair enough. Think of a fruit tree in two parts. You have the top part, which grows the branches and those beautiful Redhaven peaches.
Right.
But underneath the soil, that top part is physically spliced onto the roots of a completely different tree. That's the rootstock.
Okay, why do that?
They chose this specific rootstock because it acts as a biological shield. It is naturally resistant to microscopic soil worms called nematodes, which usually destroy fruit trees.
Oh, wow.
So farmers could plant these reliable, disease-resistant trees almost anywhere.
This scientific precision literally created an emotional anchor. The Common Orchard Project points out that Redhavens are the ultimate taste of summer past.
Because they bridge generations.
Yeah, exactly. A grandparent and a child biting into a Redhaven today are experiencing the exact same chemical flavor profile. And this obsession wasn't just limited to America either.
Right, the Romanian program.
Yeah. In 1949, Romania launched a massive national breeding program to adapt these perfect peaches to withstand harsh winters and heavy soils, ensuring their own slow food traditions could thrive.
The challenge, however, with all of this is time.
Always time.
A Redhaven peach is only perfectly ripe, where the skin yields to gentle pressure and the sugars are at their absolute peak for a fleeting window of 2 to 3 days.
So if you want to experience that late July magic in the dead of winter, you can't just put the fruit on a shelf.
No, it would rock.
You have to turn to the unforgiving chemistry of preservation. You basically have to trap time in a jar by making jam.
And moving from the romantic act of picking fruit to the science of canning is quite a pivot. I mean, it requires strict adherence to physical chemistry.
The sources show this incredible blend of, grandmotherly intuition and molecular science. First, you prep the fruit. If you have ripe Redhavens, you don't even need to boil them to peel them.
The skin just comes right out.
Yeah, the skin wrinkles and pulls right off, and if there's a bruise, you just cut it out. Food doesn't have to look flawless to be full of flavor. But then you introduce pectin.
Right. Pectin is a naturally occurring complex carbohydrate found in the cell walls of fruit. It's basically the structural cement that holds the fruit together.
Okay.
When you cook it down, you want those pectin strands to bind together into a gel network. But peaches are notoriously low in natural pectin, so you usually have to add it.
Our sources specifically recommend the pink box of powdered pectin, the low sugar variety. You mix that powder with your measured sugar in a separate bowl, but you also add a splash of lemon juice to the cauldron. I always thought that was just to brighten the flavor.
The flavor is a great bonus, but the real purpose of the lemon juice is to alter the pH of the mixture.
Oh, really?
Yeah. Pectin strands naturally repel each other because they carry negative electrical charges. The high acidity of the lemon juice neutralizes those negative charges.
So they stop fighting each other.
Exactly. It allows the pectin strands to uncoil and tangle together to form that perfect spreadable gel.
Okay, that makes so much sense. But there's another secret ingredient that absolutely baffled me. The sources mention dropping a tiny pat of butter into this massive bubbling pot of fruit.
Ah, yes.
A sliver of butter isn't enough to change the taste of gallons of jam.
Yeah.
Have you ever realized that adding a tiny pat of butter to jam isn't just for taste, but is actually a chemical safety mechanism?
It is a phenomenal piece of kitchen engineering.
What is it actually doing?
Well, as the peaches break down, they release natural proteins. As the mixture boils, those proteins trap air and create a thick layer of foam on the surface.
Right, you always see that foam.
And foam is mostly trapped air, which is the absolute enemy of safe canning. By adding a tiny bit of butter, you introduce liquid fat. That fat acts like microscopic needles, breaking the surface tension of the bubbles and collapsing the foam instantly.
Wait, so it's purely a mechanical safety feature to protect the vacuum seal later on?
Exactly. You want dense fruit, not fluffy air, going into those jars.
Wow. Okay, so to make all these chemical reactions happen, the instructions emphasize pushing the mixture to a rolling boil.
Yes, very important.
And they are very strict that a gentle simmer won't cut it. You have to achieve a boil so violent that running your spoon through the pot doesn't even disrupt the bubbles. Why does it require such extreme heat?
You're trying to accomplish two things simultaneously there. First, you are rapidly evaporating the water content from the peaches to concentrate the sugars and the flavor. Second, pectin requires incredibly high heat to fully activate and dissolve into the liquid before it can form that gel network. Once it hits that aggressive boil, you add the sugar pectin mixture, return it to the rolling boil, and time it for precisely 1 minute.
Our source mentions an amazing, intuitive way to check if this reaction was successful.
The plate test.
Yes.
Yeah.
Instead of relying on a digital thermometer, you use the classic grandmother method. You scoop 2 or 3 spoons of the liquid onto a cold plate and let it sit. The temperature drop forces the pectin to set immediately, showing you exactly what the final texture will be and confirming if you added enough sugar.
It's a perfect tactile test, but once it passes the plate test, you enter a race against temperature. You must funnel this dangerously hot liquid into sterilized jars, leaving a very specific amount of empty space at the top.
That's called headspace, right?
Right, headspace.
And you have to wipe the glass rims with a hot, damp cloth. If even a microscopic drop of sticky sugar remains on the rim, the lid won't seal properly, and the winter pantry will be full of spoiled fruit.
Then comes securing the lids. You apply the outer rings to fingertip tightness.
Which means resisting the urge to crank it down with all your arm strength.
Yes. The jars go into a boiling water bath. During that bath, the contents expand and the air trapped in that headspace is forced out of the jar.
Ah, so if it's too tight, the air is trapped.
Right. If you screw the ring on too tightly, the air can't escape and the pressure will actually buckle the metal lid.
So after the water bath, you pull them out, place them on a towel, and cover them up to cool slowly. And then you wait in the quiet kitchen for the ultimate reward.
The best sound in the kitchen.
The ping.
Yes.
That sharp metallic ping when the little divot in the center of the lid suddenly snaps downward.
It is the auditory proof of a successful vacuum seal. As the jam cools down to room temperature, the liquid shrinks slightly. Because you've forced all the air out during the boiling bath, that shrinking creates a powerful vacuum.
Sucking the lid down tight.
Exactly. Tight against the glass rim, locking out any bacteria.
Our sources note a vital final step too. The next day, before you move them to the pantry, you take the outer metal rings completely off.
You do that to test the integrity of the seal. You want the vacuum pressure alone holding that lid down.
Oh, I see.
If you leave the ring on, it might mask a weak or false seal, which leads to spoilage months later.
Okay, so you could execute this entire scientific process on a modern electric kitchen stove. It would be efficient, and the jam would be delicious.
Absolutely.
But our sources detail a much more traditional approach. They talk about hauling a massive cast iron cauldron outside, feeding little bits of wood into an open fire, and cooking the jam in the backyard while the neighbors smell the aroma drifting over the fence.
It's so poetic.
So what does this all mean? Does taking this process outside actually change the food chemically, or is it just about the experience?
Oh, it fundamentally changes the chemistry of the food. Oh, yeah. If we connect this to the bigger picture, when you transition from a sterile indoor stove to an outdoor wood fire, you are introducing new, highly active variables. First, the heat. A mature wood fire can easily generate temperatures exceeding 700 degrees Fahrenheit.
Whoa!
This intense raw heat triggers rapid Maillard reactions on the surface of the fruit.
So we aren't just boiling the peaches, we are caramelizing them.
Precisely. The natural sugars and amino acids in the fruit break down and recombine into hundreds of new, complex flavor compounds.
That sounds amazing.
You get toasty, nutty, deeply caramelized notes that a conventional stove simply cannot replicate.
But the fire isn't just a heat source, it's giving off smoke and steam.
And that is the second major variable. Burning wood releases carbon dioxide, water vapor, and volatile organic compounds. The water vapor creates an envelope of steam around the cauldron.
Keeping it from drying out, right?
Exactly. It prevents the bubbling fruit from drying out too quickly. But the real magic lies in the smoke itself.
How does the smoke actually get inside a pot of boiling jam, though?
As the cellular structure of the wood, specifically a polymer called lignin, breaks down in the flames, it releases a compound called guaiacol.
Guaiacol.
Yes. Guaiacol is the molecule responsible for that intoxicating, deep, smoky aroma. From a chemical standpoint, smoke loves moisture and fat. As the glycol molecules rise on the heat currents, they physically latch onto the surface moisture of the bubbling fruit.
Wait, so the smoke essentially seasons the jam?
It literally becomes a chemical ingredient.
But practically speaking, trying to manage a delicate pectin reaction over a chaotic 700-degree open flame sounds like a total disaster. A fire doesn't have a medium-low dial. How do you keep from just burning all that sugar?
That is where the engineering of the cauldron comes into play.
Yeah.
Our sources reference the traditional Romanian cooking vessel, the cien, which is a heavy cast iron cauldron.
Ah, cast iron.
Cast iron possesses incredibly high thermal mass and a high specific heat capacity.
Meaning it acts like a heat sponge.
Exactly. If you put a thin aluminum pot over a fire, the flames will create violent hotspots that scorch the sugar instantly. But thick cast iron absorbs the erratic, aggressive energy of the flames and distributes it. It radiates the heat back into the fruit slowly, deeply, and evenly. It takes the chaos of the fire and turns it into patience.
Which is why the cien is the absolute heart of traditional slow food. In Romania, they don't just use it for jam.
No, it's used for all sorts of things.
Yeah, they use that thermal mass to slow cook tocitura, which is this hearty pork stew that simmers for hours, and they serve it over manalaga, a thick cornmeal polenta boiled right in the cauldron.
Usually cut with a thread, traditionally.
Yes. They use it alongside memory-heavy foods like sarmale, those sour cabbage rolls stuffed with minced meat, or to fry papanai.
Oh, the cheese donuts.
Golden cheese donuts smothered in sour cream. And what do they top those papanai with?
Homemade fruit jam.
Homemade fruit jam. It all connects. When you stand by that fire, constantly stirring the cauldron so it doesn't boil too fiercely, waiting for the water to evaporate, you are participating in a massive sensory event.
You really are.
You are combining the strict physics of pectin and vacuum seals with the ancient primal comforts of wood smoke, thermal mass, and those guaiacol molecules.
Wood-fired cooking isn't just a cooking method. You are creating an environment that bypasses the analytical thalamus and speaks directly to the limbic system of everyone standing around that fire.
We've traced such an incredible journey today.
We really have.
We started with the architecture of the brain, uncovering why a simple scent can act as a time machine. We looked at the mid-century botanical science that gave us the perfect Redhaven peach.
A true masterpiece.
Yeah, and then we unpacked the high-stakes chemistry of pectin, pH levels, and rolling boils. And finally, we stood by the radiant heat of a cast-iron cauldron to understand how wood smoke physically transforms our food.
It just reinforces how deliberate these acts of preservation are. And there is one final piece of neuroscience that really ties this all together.
What's that?
Our most powerful, unshakable olfactory memories, the sense that define our baseline sense of safety for the rest of our lives, they are almost entirely cemented in our brains before the age of 7.
Wow. Which means the aromas you are creating in your kitchen and backyard right now aren't just a fleeting experience for you.
No, they are the permanent emotional inheritance you are leaving for the children and family members around you.
That is beautiful. And our sources mention one final, slightly rebellious act at the end of the jam-making process.
Oh, leaving one jar out.
Yes. After sealing dozens of jars for the winter, you purposely leave one jar unsealed. You let it cool and you eat it right then and there. Spoon generously over a slice of freshly baked bread with melting butter.
Taste in the wood smoke and the summer sun. A reward for the work and a preview of the winter to come.
Exactly. So as you go about your week, whether you are boiling water for tea, crushing garlic for a stew, or lighting a fire in the backyard, think about this. What deliberate, comforting scents are you cultivating in your home right now that will become the anchor of safety for the next generation 20 years from today?